Hello, everybody. Welcome back to Shit You Wish Your Building Did. This is the podcast where technology experts tell you how to make your building smarter. And today we are speaking to Gabe Fierro, Assistant Professor of Computer Science at the Colorado School of Mines, about smart building metadata schemas. Why? Because metadata schemas are converging and increasingly complementing each other. Stick around for this important conversation. If you're serious about making your commercial building smarter, then you are in the right place. Every episode, we talk to an expert in their field and discuss practical advice on how to implement technology in buildings. Subscribe to the channel and you'll be notified when we publish new content. So let's go. Gabe, Assistant Professor at the Colorado School of Mines and co-creator of the Brick Schema. Welcome to the podcast.
Thanks so much for having me.
Yeah, real pleasure to for you to come on and talk about your work, which I find fascinating. So I'm sure it's going to be a really interesting conversation. I thought maybe we could start with, I think generally, and I'll put a description in the show notes, but most people, I imagine, know or have heard of Brick, but perhaps you could just bring us up to speed on, where the project is now and what you guys are working on at the moment.
Yeah, absolutely. So we, as a collaboration of researchers and from academia and industry, started Brick in 2016. I guess we technically had the first conversations in 2015 with the intent of how do you model a building for the intent of making data easier to find so that you can go and write sort of data-driven applications. In terms of where we are now, we're getting to the point where we're pretty confident in the design, that the design is sound, and we're currently in the process of making sure that Brick works well with the other prevailing digital representations for buildings. It was never our goal to sort of eat the world, right? Be the one true representation of all metadata in buildings. And as our understanding of, and as the landscape of other metadata solutions and other sort of digital representations of the buildings expands, we see our role as trying to make sure we can be a bridge between both sort of higher level user-facing representations, maybe emerging lower level representations, things like ASHRAE 223P, and be a structured representation that makes it easier to write certain kinds of code. One of the things that's become sort of clear is it's Brick and the world of what we would call sort of graph-oriented or RDF metadata is not necessarily what you would want to give to any engineer or to any developer or any property owner, but it is, in our opinion, a very good basis for establishing what those user-oriented abstractions might be. And I think if I were to try and to summarize the two directions of work, it's integration with existing standards, existing and emerging standards, and then making sure that we're continuing to support data-driven applications in a way that is best fulfilled by the current design.
Right. And to dig into that a little bit, and perhaps I think the main reason that I asked you to come on today was to talk about how you see some of these different metadata models coming together. And you've talked about, I think, this complementing, right, rather than competing metadata models, right, rather than them being distinct. Now they are working more together.
Yes, yeah.
So I mean, let's talk about that and get into that. So what would you be your, where do we start with that?
Yeah. So one of the pieces that first emerged for us was when Brick was created. The prevailing solution in this space was Project Haystack, which at the time was really more of a sort of tag dictionary rather than the more elaborated data model it's sort of grown to be in recent years. So version 1 of Brick you could very much see as, it was providing a name to a set of tags that everyone could agree on. Mm-hmm. Over in And then we kind of got away from that a little bit and leaned more into the graph-oriented nature of that. But I would say the first major step we took towards realizing, hey, maybe we should be working better with other metadata solutions was the emergence of Real Estate Core, focused more on spatial elements, on property management, asset management. And what we sort of found was, our scope of starting from HVAC equipment and points onto equipment, and we started to have to model more spatial stuff, more of the asset management. And then Real Estate Core was starting from modeling spaces and property, and over time they were modeling more equipment and more points and data sources. And so we had both well-established domains and that we were slowly leaking into each other's solutions, and we started borrowing from each other's solutions. We were using some of their concepts for locations. They were using some of our concepts for equipment. And at some point, I think they reached out to us, and we said, why are we duplicating this effort? Can we instead, because we're both using the same graph standard for writing down these metadata ontologies, can we instead just make sure that anytime Brick needs to refer to a location, it refers to a Real Estate Core location? And every time Real Estate Core needs to refer to equipment or data, it refers to Brick equipment or data concepts. And so what sort of became clear was we could each continue to develop our sort of core competency without, and make as much use of a good solution that we didn't have to then manage. And then the communication was all about, how do you make sure that when someone has a modeling task or someone has a question they want to ask of their metadata representation of a building, that it's clear what representation they go to find that information, right? Just like when you want to ask a question about something, maybe you go to a certain website for these kinds of questions, you go to another website for these kinds of questions, or a different area of the library, right? Those kinds of metaphors. And so that was probably the first one where we tried to clearly articulate the boundaries between metadata schemas. And that's one form of that, which is subdividing a very large domain, buildings, into smaller pieces that can be well modeled. And it's one of these fundamental trade-offs that the bigger of a subject area you try to model, the more generic you have to be, the less specific you can be. And so we've tried to find what you might call the knee point between sort of complexity and usability in terms of how much of a domain we cover and how we approach the modeling of that domain. Mm-hmm. As newer, so ASHRAE 223P is the other big one in the space, and that's why I'm here in Tampa to talk about ASHRAE 223P. It's a much longer story in terms of how 223P works in this space, but essentially, we think of it as maybe the Lego blocks or the atoms, the building blocks underneath higher level representations. 223P may not, have I think in Brick we've got 800 or 900 different classes of equipment and points and things like that. ASHRAE 223P will probably not have that. It'll be a much shallower hierarchy, but it will name the building blocks from which I could go and construct any weird VRF system or any weird chiller plant or anything that I want to do. And something like Brick or Real Estate Core can exist on top of that as a way of mapping very detailed information, simplifying it into something that's more maybe accessible to a human or to a programmer. The other big integration that we've been working on is with Project Haystack. With the launch of the Zito type system that Brian Frank mentioned in the latest Haystack Connect, there's now an opportunity for us to provide sort of well-structured translations between a Haystack model and a Brick or Real Estate Core model. And so one of the things I'm actually demonstrating at ASHRAE today is the ability to go from this very detailed ASHRAE 223P model generate the brick and real estate core model in the middle, and then generate a haystack model on top. And so you've got the same building modeled at multiple levels of abstraction. And in this way, rather than competing in terms of whose job it is to model the whole building, now it's a question of, depending on the job you want to do or the question you want to ask, I might reach for a different representation. And the programs that we've been developing, the fact that we're building all of these on these graph standards, means that we can ensure that they're all kept up to date with one another.
Right, because underlying all of this, and you've referred to it, are these graph standards, which are, Web3 compliant, like they're standard across the IT industry, and that's, I guess, a huge advantage, right? Because it means that, for example, integrating or making brick and real estate core work together was a lot easier.
Yes. I mean, these are actually standards that go back to the original vision of the internet from Tim Berners-Lee, that any resource would have, any online resource like a page would have structured information about what the content was, how it related to other pieces of content. And what we've done is, even though his vision of the web hasn't quite come into fruition as he imagined it, right, in this, what you might call the semantic web in the early version of this.
Sure.
The ability to link information together in this very flexible and dynamic way has proven really powerful. And it also, there's a ton of software that's already out there that we can use to store and manipulate this data. So we don't have to go and create all of that from scratch. We can just lean into an existing ecosystem, which has been very, very helpful.
And I think those levels of abstraction you talked about are really important as well, right? Because I suppose, and you said people doing different jobs need different information, different data at specific times, and allowing that is important, right? Otherwise it becomes, I guess, confusing for people and ultimately not useful.
Oh yeah. I mean, the example that I go to is if I want to get a list of VAVs in my building, it's hard to get easier than just typing the VAV tag into the Haystack, the Axon search bar right at the top of the SkySpark interface. I type VAV and I get a list of my VAVs. That's very convenient. That's very easy. If I, maybe for some fault detection application, or if I'm creating a detailed model or a simulation of a building, I might have a differential pressure sensor. In Brick, in Brick and Haystack, I can both say, well, where is that differential pressure sensor in terms of what equipment is the differential pressure sensor about? But if I want to figure out where exactly is it measuring differential pressure, right? It's got two of those leads, and it's going to measure the pressure between those and calculate the differential, or measure the differential. Where exactly are those leads? That's a level of detail and precision that's much harder for Brick and Haystack to model. So there's a lot more of the building you need to be able to express, and that's exactly what something like 223P is designed to provide.
Okay, yeah. So how would you recommend that people should plan for this, or at least, as this new direction of metadata models coming together?
Mm-hmm.
What does it mean, do you think, on a day-to-day level for people working with data?
Sure. It's a great question. I would say two things. One is, hopefully this helps engender a culture of holding on to a lot of the existing data. This has been one of our primary struggles, is a lot of the things we're now seeking to model were known at some point, but due to handoffs or just the way that information moves through these sort of exchanges from firm to firm over the life cycle of a building, things get lost or they don't get maintained. And so we are still actively working with standards like IFC, right? Or trying to integrate with software like Revit to make sure that in places where Brick, Haystack, 223P don't excel, something like modeling geometry, we can point to a model that's good at that, right? That our tools already exist. We don't have to solve that problem. All we have to do is link into that. And so by making sure that there's still utility in using that data, hopefully this helps in, keep your IFC models, keep your Revit models, because it will help you to create your 223P, your Brick, your Haystack, real estate core will help you create those models. In terms of the other way of how you might think about this, we've been undertaking a series of projects in integrating semantic metadata into existing BMSs or existing data management solutions, things like like Niagara, things like PySoft, where you can think of metadata almost as a layer on top of an existing data solution. So if you already have a data historian, if you already have a message bus that's transmitting data between pieces, what something like 223P Brick can do is they can exist in a separate metadata database alongside your existing data solution. And anytime you have software that needs to discover data or needs to know how a piece of data relates to other things in your building or other data sources, it can go and query the metadata store that contains all of that information to ask for, hey, what are all the points on this equipment? Or, what's the upstream temperature of this piece of equipment? Or where are all the meters the sub-meters on this floor, or, whatever that question happens to be. And that's, right now, we're trying not to be too opinionated about what it looks like to adopt that. But this is, we're very, very open, right? A lot of this is, I'm coming at this from the academic perspective. I have a set of principles and things that I think work. We do have open working groups, so anytime someone has a question about how does this work or how do I integrate this, we're always happy to engage. Because our goal is not to tell people what to do, but we want to figure out what works for people. And sometimes you have to assert the wrong answer in order for someone to tell you what the right one is. But currently, it's a you could think of it as a store that's maybe parallel to your existing data solution that layers the semantics on top of whatever you currently happen to be using.
Right. Okay. Of course. I think that's a pretty good segue, actually, because one thing I wanted to ask you was about, common misconceptions that you think about metadata schemas. I suppose, where they should be used and how they should be used. I feel like sometimes there is a disconnect between, let's say the academic view and the data view as opposed to the building owner, building FM view.
Sure, yeah.
What's your thoughts on that?
Well, I think the high order bit is no matter what you might read about these so-called ontology wars, anyone who's actually working on any of these metadata projects really does believe and really is actively working towards bringing them together. Not necessarily to a single standard, if that's a capital S standard or lowercase s standard, but at least making sure they work together and that there's a clear path for them to complement one another. So that's something we're all working on. The 223P folks, Real Estate Core, Project Haystack, Brick, we're all actively working towards that sort of unified vision. In terms of the misconceptions, I think one of the main ones is oftentimes Brick and Haystack get compared. And in terms of usability, Haystack is absolutely the winner there, right? It's designed to be accessible by facility managers, whereas Brick is coming. We have this whole alphabet soup of it's RDF and it's Sparkle and it's Shackle and all of these existing. They're existing standards, but they're not necessarily something you would learn if you're learning programming, right? Or you're learning information technology. This stuff doesn't usually get brought up, and so maybe the misconception is that this RDF stuff, the graph stuff, is what should be used by facilities managers and building managers. It is a very sort of persnickety, low-level representation, and it can be difficult to express questions against that and learn the query languages. So our intent and the things that we're actively working on is how do we make that more usable? I don't think it's you can think of Brick and 223P almost as the assembly languages, right? As writing C code or assembly code, where you do have to be very specific, right? If you make a mistake, the computer thinks that mistake was deliberate, and sometimes your program crashes. But you do need that representation in order to facilitate something that is easier to use. Your Pythons, your JavaScripts, your TypeScripts, your BASIC, maybe even as a programming language metaphor. So I think that's a misconception that Brick should be used directly by these people. If you want to learn, we're happy to teach you.
Sure.
But we think there's definitely room for better abstractions on top of that. And a lot of these smaller analytics firms that have been exploring the use of Brick, they've been doing that. They've been finding their own ways of working with that metadata. And Haystack and the SkySpark and that industry of products is a great example of the kinds of higher level user-facing, user-friendly interfaces that you could provide. And in our vision, Brick is one way of translating sort of very detailed low-level data from something like 223P into a Haystack model directly, so you can always derive the high-level representation.
Because the value, I mean, certainly from like the building owner or the operator perspective, the value might be much higher up.
Yeah.
But what you need, what it's doing is working at the lower level. So, I mean, it could be just provided as part of some software that you purchase to do a specific job, but like it's still extremely important to have that metadata there.
Yeah, exactly, right.
And I think one thing as well, I've when I've mentioned it to people as well, is like understanding the practical applications of it. And I think, as you said, like perhaps it suffers a little bit from some of these quite technical computer science terms, but to put it in sort of more straightforward language, like what do you see as the value to a building owner operator of using Brick, Real Estate Core, Project Haystack?
I think it is I think it reduces integration effort by not just making sure that the configuration information, the information you would need to configure software, is available, but also available in a structured and consistent way, which means that there's less reading binders of what's there inside the building and the point abbreviations. It's less clicking around in BMS interfaces designed to give you the operational state of the building, not designed to tell you how the building is put together and how the subsystems work. It gets us closer to this vision where software, if that's fault detection rules, if that's control sequences, can be auto-commissioning because the software is able to perform what we would call introspection on the building. What's there? How's it put together? What sensors did you install? What actuators did you install? How are those presented in the BMS? Now I know what control sequence is the most suitable. I know the fault detection rules that I can run. And because everything is labeled consistently, there's less human effort required in sort of wiring those things together, right? So ideally, this is fewer truck rolls, right? It's fewer hours spent by engineers or facility managers working together to make sure that everything's hooked up. At some level, you could think of, what does structured metadata provide is something close to the red squiggly line that you get underneath a grammatically incorrect sentence in Microsoft Word, right? Like there is an understanding of grammar behind that. There's an understanding of rules of what can be expressed, the valid ways of expressing it. And the system helps you as the user make sure you're doing things in a way that is communicating clearly and consistently. I think it's still emerging what the tooling and the workflow is that helps these models be created, but our goal is to understand better the existing workflows of people that are doing commissioning of the BMS, that are installing and configuring software. And maybe with a few tweaks to that, right? If you're already writing down a name, if you change the name slightly, or you've got a tool that helps you choose from an existing existing set of terms, whatever that happens to be, maybe with a few tweaks, we can make it much easier to generate and maintain this metadata, and it becomes basically part of the interface of your building, right? In the same way that my laptop has USB ports and it's got an audio jack, and as long as the connector looks the right way, I know I can plug in a piece of I can plug in a mouse or a keyboard, or I know I can run Word or Chrome or whatever that is. I don't have to worry too much about what kind of CPU I have or what kind of memory or what kind of hard drive is actually installed in the computer. Generally speaking, the computer just figures it out, because at some level, people had a conversation about what's the interface between the stuff that's user-facing and the stuff that's underneath that actually helps this stuff go.
No, great point. I think my final question to you as well is sort of the role as well of the vendors, software vendors, because I think, actually in terms of like from the metadata perspective, like they have quite an important role. Do you think that, are you seeing like that there are emerging roles for new startups or companies to take advantage of, or what does the landscape look like to you?
Sure. I mean, I should preface this with I've never had a real job, right? I've just existed. I've just existed in academia, and so I would encourage people to definitely come, send me an email, come talk to us. This entire effort from day one, Brick has been driven from not this. We've really tried to avoid the ivory tower perspective that we know best and we're going to tell you all how to do it. It's really been driven day one from what are the things that people actually need to do. And if there's anything wrong, it's in how we've been perceiving what that is. Can you repeat your question? I'm so sorry.
No, just about how the roles that might be fulfilled by emerging vendors.
Yeah, that's right. Yes, sorry. So I think it's a couple things. One is we're hoping for a version of this industry where the data model is not a competitive advantage necessarily, right? Getting people into a particular ecosystem of how things are described is not what differentiates. I think a lot of emerging firms, analytic firms, really want to compete on the quality of their analytics. They want to compete on the quality of their rules, the quality of their controls and their models. And so having structured metadata already there in the building reduces the onboarding time for them to get their product in there and for them to demonstrate value, right? There's less of this extensive onboarding process, of this integration process of like, well, what did you buy? What's in there? How is that described? Now we have to map that into our system. And if you look at many of the early players in that sort of building analytics space, that was exactly what they were doing, right? They have their own internal model that they needed to develop in order to actually go and get things done. And I think if we come together as an industry, right, we almost democratize access to that kind of data and make it much, much easier for firms to compete on the quality of the quality and value delivered to the customer, rather than how quickly they can get into a building, right? That's not necessarily the best use of your engineer's time, right? You hired them for other reasons rather than just hooking up. What does ABC mean in this building? So I'd say it's that, right? In the way that all of my metaphors are computer related. So like you look at the early days of the internet, right? Being able to lift the abstraction using the internet protocol to the point where basically anyone could talk to anyone, right? These network effects of available information and available resources, you were able to abstract away the differences between, how these internal networks worked, in the same way that we might be able to abstract away some of the differences of how it is you talk to different buildings and how equipment and points are described. That in these future firms, you may not have you might have one sort of metadata person, right, that really knows the details of these models and how to get that working, and the rest of everyone else is sitting on top of Python or JavaScript or some high level representation that's much easier to get the actual work done, rather than having to know every single detail all the way down the stack.
Yeah, that's a great point. Gabe, thank you so much for your time. I'll make sure we put a link to some of the projects we discussed. So I'll put Brick, Project Haystack, ASHRAE 223P, and Real Estate Core. I'll put all the links to that in the show notes. But yeah, and I guess as you mentioned, you're happy for people to reach out if they want to ask questions or ask Brick Schema related questions.
Yes.
Cool. Thanks again for your time.